Good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
Yes. So this is the fourth week. I am Elsa Sharu Johnson from NIT Tiruchirappalli. Yes. Today I am going to discuss the Week 4 assignment, which was given in the previous run course of this particular Python for Data Science course. So this will be helpful for you to solve your present Week 4 assignment. Okay. So let's move on to the first question. Before that, I hope most of the people are here. Yes. So the given data is a credit worthiness data here, containing 1,000 observations of income details. So I'll just show you what the data looks like. So this is the number of variables in the data, and these are the descriptions of the data. So CBAL means balance in the checking account, and the type of that data type of each of the variables is also given. So this is present in sheet variables of this data, and the data itself is present in this format. Okay, there are about 21 columns. There are about 21 columns totally, and so I think you can't see the screen. Wait, I'll just share once more.
Not visible.
Yes, I'll share once more. Yes, I'll once more show you the data set. This is the credit worthiness data set. Okay. And here the variables, these are the variables: CBAL, CDUR, CHIST. Okay, these are all the different variables there, about 21.
Ma'am, it's not clear. Can you please zoom it?
Okay. Yes. Mm, okay, please wait. This it's not responding. Okay. Yeah, well, please wait for some time. Okay, I'll just share once more. So this is the data, CBAL. I think this is visible now. Yes. Okay, so this is CBAL categorical. Type of data is categorical, and these are the rest of the variables present, and the data type of each of the variables is given. Okay, I'll share this data set later. So these are the different columns which are present. Some are numerical, as you can see, and some are categorical. Okay, so then this is the target variable, like chances of the borrower closing his credit promptly, categorized as good or bad. So our intention is to categorize the borrower as a good borrower or a bad one. Okay, so based on that, we'll be giving the money. Okay, so this is the income details. Okay, so credit worthiness. So by observing, so our problem statement is by observing the features of the data set. The problem statement can be identified as a binary classification problem of classifying any individual into an appropriate category of credit score as good or bad. So this is our intention. So in this particular data sets, then now I'll show you the different types. So this is the whole data set, about 1000 entries are present, and this is how the different data will look like. So for example, C balance will be like these different classes are there, and duration is a numerical type data. And then history is like all settled till now or dues not paid earlier. All those different types are there. Then purchase, CPUR is purpose of the loan, like variety of needs from vehicles, furniture to housing. So it's like business, electronics. That is the purpose. Okay. Then amount, like that, everything is there till the 21 columns, and the target one is good, either good or bad. Okay. So we'll move on to the Colab notebook. So here the first question is, based on this data set, how many unique values are present in the SBAL feature? SBAL feature. So here the SBAL is like this one, rupees less than 1000, no savings account, like that. Different divisions are there for this data. So based on that, we have to find out how many unique values are present. Okay, so first we have to read this data. So the first step is to import the required libraries which are needed. Okay, so for importing that, I'll just increase it. Okay, so for importing that, I'm just importing the required ones. Later we'll import the others as required in the program. So first I'm just importing NumPy and pandas as NP and PD respectively. I'll just run this one, and my next step is to load my data. Okay, so this credit worthiness, I have just split the data into just the data itself in a sheet called data, as well as a data file, Excel file containing the variables and data. Okay, there is an objective also, so that is not clear which way they have given. So these will concentrate on these two sheets, variables and data. And so first I'll just show you the different ways of loading. I mean, the first one, in the first case, I'll load the credit worthiness only. Okay, and I'm just loading all the different other data sets also, which is used today. So I'll just open all three. So these are getting loaded. Yes, they are loaded. So the first one, credit worthiness. So the credit worthiness data set has only the data. All right. So only the data means the description of the data is not there. Okay. So I'll just read that data here. And first step, I'm going to see what are the columns. Okay, so when you get a data, your first step should be like, it's a norm actually, like you just see what are the data. So you can either do the head or sample or tail. Okay, we just want to see how the data looks like. So you will get 5 rows with the different data available. Okay, so this is the first thing that you have to do. You have to observe the data. Next, you have to find the information about the data. So in the information, you can see how many objects are there, what are the data types of the different objects there, and how many non-null objects are there. Okay, what are the different columns that you can see.
Madam, excuse me.
Yes.
In data type, there are 2 types of data types mentioned. One in object and another is int. So what is object exactly?
It's usually used to define your categorical data actually.
Means it may be character, it may be numerical.
It can be like 1 or 2 which denotes a class actually. For example, if I am classifying the customer as good or bad, maybe you can code that good as 1 and bad as 0. So in that case, that also will be a categorical, even if the numerical values are present. Okay. Is it fine?
Okay, ma'am.
Yeah.
Madam, can you tell me the difference between object and categorical data?
Yeah, categorical data means you'll have particular divisions. For example, in this CBAL, that is the balance. This is the different types actually. You can see that the CBAL means balance in the checking account. So the customers are classified as, if the balance in the checking account is between 0 and 2000, they are one class actually. Okay. Next is no checking account. They don't have any checking account. They are a different class of customers. Then another class of customers will be like rupees less than 0. I'm just basing on this data set, okay? So, and another class would be like, we'll see how many different classes are there. So this is like, you are splitting your data to different classes. This is actually given in the data set only. We are not changing anything. But based on this data, by looking at CBAL, we can see that there are different classes. For example, you can see numerical values here, but this is not numerical value. Numerical value just means that you can look at the duration, see duration, CDUR. CDUR means duration of credit in months. So that is coming as a numerical value. But the other one, this one is like a categorical value. Your customers are classified as into different categories based on the balance in their checking account. Okay. Are you fine with this one?
Madam, now can you differentiate with the object?
Yeah, so this one will, when you read this into a Python, it will be coming as an object. You can see here. If I run this one, the first thing will be coming as an object here, because it is having no integer values present. It is having integer values, but some other characters are also coming. So it is taken as an object there. Okay, so all the categorical values will be taken as an object here. Is it okay?
Okay.
Okay. So Anvay, I am discussing the previous run assignment. We are not instructed to discuss the present assignment with you. We are only instructed to discuss the previous assignment. Yeah. Okay, so this is the data. Now I'll just give the data.describe. This is the fourth step which you have to do after you get a data. So data.describe will give you the count, mean, standard deviation, minimum value, 25% of the 25% quartile, then 50%, 75%, and maximum value. Okay. So if you do a data.describe, it will come only for the numerical values. So in numerical columns actually. So this will show how much is the count, how many data are present, what is the mean, and their standard deviation, minimum and maximum values, and the values which lie in the 25, 50, and 75 percentile. Okay. So if you want to see your categorical variables also, then you have to give data.describe, include the object values also. Okay, so include equal to, if you give like this one, you'll get the data about, you'll get the description about your object values also. So if I run this particular one, you can see CBAL, CHIST. CBAL is the first one, which is a categorical thing. So you can see the count unique, but in that case, when you include the objects also, then you won't get these things, mean, standard deviation, etc. All those won't be coming, because those are not numerical values, they are categorical values. So I'll just restructure this one. I'll toggle this data which we are getting, and for that I'll just put .t. So in that case, I'm getting CBAL count 1000, number of unique numbers equal to 4. Then the stop will give you the most recurring category in that particular column, and frequency will give you the frequency of occurrence of the most the most occurring category in that particular column. Okay, for example, we have been asked to find about SBAL. Okay, how many unique values are present in the SBAL feature, and what is the most frequent value within SBAL. Okay, so the options were given like this: number of unique values and what is the most frequent. Okay, so looking at this value, you can see that in SBAL, this particular column, there are 1000 counts. Number of unique numbers, number of unique entries in SBAL column is 5. The most occurring one is rupees less than 1000, and the number of times it occurs is 603. Okay, so just doing this data.describe and including the objects in that will give you the answer. Okay, so the answer will be like 5 and rupees less than 1000. So option C is the answer. Okay, now
Ma'am, here is what is the present dot t?
toggle. If I just give this particular thing, okay, I'll be getting the value like this one, like a row. Okay, now this its appearance can be changed by toggling it. Okay, I mean just transposing it. So this is the transposed thing. Okay.
Yes, ma'am.
Yeah. Now there are other ways also. I mean, you don't have to do a describe to see the values. So another way is like, you know what is your data frame, you know what column you have to check. So in that, if you just type n unique, you can get the number of unique values in the SBAL. Okay. So now if you run that particular thing, you can see that there are 5 unique values in SBAL column. Okay. This is what you get from the describe also. Okay, this is just another method. And if you want to see like how many, I mean data.sbal is the column. Okay, so I'm just putting this to an array. So we want to see what are the number of unique elements and their frequency, right? So I'm just converting, since I'm using an NumPy, I'm just converting it to an array. And just I am putting np.unique using NumPy library. I'm getting the unique values. Okay, so I'm given this particular data into a NumPy array, and I am giving return count equal to true. So because I want to see how many times the unique elements are repeating. Okay, so if I run this particular thing, then you can see that the unique elements are the first one, this one. Another type is this. So 5 types of unique elements are there, and the frequency of unique elements. So the first type is this one, then next is like this, next this one, then this one, and no savings account is the last unique type. And the frequency of each. So you can see the third one is rupees less than 1000. It has a frequency of 603. So that is the top recurring class actually in that particular column. So this is another way. Okay. So I hope you understood the first question. Does anyone have any doubt?
No, ma'am.
Okay. Then we'll move on to the next question. Next one is find the average age of customers who have a credit history, C-hist, wherein the dues are not paid earlier. Okay, so C-hist is like this one. C-hist is also a categorical column. Does anyone have any doubts? Okay, so C hist is also a categorical column. It gives the pattern of credits dues payment over time, whether the borrower has paid his monthly dues promptly. Okay, so now the data will look like this one: all settled now, dues not paid earlier, none taken, or all settled. Like this, the different categories are coming in that particular thing. Okay, so if is anyone having any doubt? Okay, so this is the data, and after that we'll go on to
Madam?
the yes.
Madam, I have a doubt.
Yeah.
You said these are all categorical variable types, no, ma'am?
Yes. Not all. Some.
Yes, ma'am.
Yeah.
But when you see the info, it is coming like object, no, ma'am. Why it's coming like that? It is not coming like a category type.
It won't show as a category like that. It will show like an object when you load that into Python. Object means what? It is a type of a string. Okay. It has a kind of a string value. It is not numerical.
Okay.
Okay. Yeah, so the next one was see history. That is also a categorical. So we'll see how to see the average age of customers. So age is numerical. That you'll know, age is numerical only, but see hist is categorical. So first we have to find out the number of people who have not paid the dues earlier. Okay, so first what we have to do is data of hist. Okay, this will give you the column of C hist, and we'll check this condition like dues not paid earlier. Okay, so if I just take that itself and just see the len, you can see how many people are there like that who have not paid their dues earlier. So okay, so so okay, just wait a second. So I'll just see how many are there in data who have not paid the dues earlier. Okay, so if I put that, you can see that about 293 people have not paid the dues earlier. Okay, so I've just put this condition, data of C hist equal to dues not paid earlier, and I'm taking this condition inside the data frame. Okay, so about this much people are there. Now I am just taking that particular number of people. Okay, so this much people are there, 293 people are there, and from them I am extracting their ages. So I am just extracting the ages of all those people, and then I'm finding the mean. So I have to give, like, first I have to take data of this much, and then their age dot mean will give you the mean of ages of all these 293 people. Okay, now I'm just printing the paid due age which contains the data, and I'm rounding that data up to 2 decimal points. So it will give me 38.44. Okay, so these were the options, and B is the answer for that one. Okay, so I hope this is clear. Just I have taken the condition and I have put that in the data. Okay, so
Madam,
yes, tell
madam,
me.
can you explain me the first line, madam?
This line?
First line, length of that data.
Okay, this one I have just given, like, this is the condition. Our data frame is data, it's named as data, and in that data I have a column. C hist is the column. Okay, so you know that there are 10,000 entries. Okay, there are 1,000 total entries. So in that itself, I am checking this condition. I'm checking the condition where dues not paid earlier. For example, in this particular data, this is one of the entry like given dues not paid earlier. Okay, so I just have to take these all the places where dues not paid earlier entry is coming, and from them I have to take the age. Okay, so I'm just finding out how many people are there. Okay, tell me.
Madam, it is in a column now, madam.
Yeah, this is a column. Yes, this is a column. See, hist is a column. Okay. In that column itself, I'm checking the instances where dues not paid earlier is coming.
Okay.
Yeah. So I'm first, in the first line, I'm just checking how many people are there. Like that condition, in that condition. And then I'm taking the particular data. So in that particular data, if I give this, all the people who are in that particular data will be coming, and from them I'm extracting the age. Okay. So then I'm finding the mean. Okay. I think this is
Okay, madam.
understood. Yes. So then I'm printing it. Okay. So that is B is the answer. Now line number 18 is similar to group by function. Yes, you can do it using group by also. It is similar to that itself, but there is no, I mean, we only have two types of data. We just want to find chist and as well as age only. Okay, so you don't have to use group by or anything for doing this one. Just you can do like this one only. Okay, we are just, yes, okay. Now, the third question is a logistic regression model is built in which none of the features used are standardized. The trained test proportion is 75:25 and the random state is set to 1. Okay, the accuracy of the model is asked. Okay, so I hope you have seen the week 4 slides about classification and regression models. So I'll just move on to this question. So the first one, I'll just import some things which are needed, not needed as much here because I'm not using any visualizations here, but still I'm just loading everything. Now the things which are needed are like train, test, split, logistic regression, and when we want to, anyone having any doubt? Okay, then accuracy score, confusion matrix, classification report. I hope you have gone through everything. Otherwise, I mean, I have given certain links also, like if you want to know what is train, test, split, it splits arrays of matrices into random train and test subsets. All the parameters and the values which returns is present in this link. You can go through this. Okay. And about logistic regression, I have given one thing, that is the API reference of that scikit-learn library. And then the metrics of scikit-learn, which will show you the different metrics like accuracy scores, precision score, all these things. You can just go through that by clicking these links. Okay, I have just given you a bookmark for that. And so we'll move on to the program. First, I have to read this data. So in this, I'm just reading the full data itself, and I'm just giving like sheet name is equal to data, because in the sheet, data or data is present. Okay, I mean required data is present. So this thing, creditworthiness full, that full data set is present there. Now I'll just read that into the data frame data, okay, which was used earlier itself. Now the next one, I mean, we were used to build logistic regression models in which the data are not standardized. Okay, so we'll go on to the standardization later, but right now it won't be standardized, and in that case we want to find the accuracy. So first what I'll do is I'll load the data. Then what I'm doing is like my target variables are either like good or bad, so I'm just mapping them, I'm encoding them like 1 or 0. If the credit score is good, then I'm putting as 1, and if the credit score is bad, then I'm putting as 0. Okay, so this is, I'm just, so right now our data will be like data. I'll just show you how it looks like. I mean, what will happen there? The target variables will be coming as 1 or 0. Okay. So the 21 columns are there. The target variables credit score will be mapped as 1 or 0. Okay. Now, next one, what I am doing is like pd.getDummies. So this particular function is used, I mean, you might know it is used for data manipulation. It converts the categorical data into dummy or indicator variables. Okay. So if you give a list, then you will be converting that particular target variable into different sets actually. Okay, different sets means different other indicator variables. Okay, so for that I am using the get dummies function. Okay, so after this you can see what happens to our data. Okay, so just before doing that, I'll just see what are the different columns present in our data. So data.columns will give me, these are the different columns present in our data. Okay, then after that I'm just doing the get dummies function. Okay, so get dummies, I'm in my data, I'm just dropping the target column because I don't want to encode my dependent variable. I just want to encode my independent variables like the other rest of the target column. Okay, so in that, what I'll do is that I'll drop the column with this credit score, because in the credit score we have already mapped it as 1 or 0, so it's not required. So I'll drop that particular column, and then I'm doing like drop first equal to true. Drop first equal to true means the original column will be dropped. Okay, original column which was already present. So the columns which were present earlier were this one. Now if when I run this one, and I'm also giving like in the y variable, I'm getting the giving the target. Okay, so if I run this, you can see like what happens. I'll just show you right now. So I have given the get dummies function, and if I put like x dot columns, that is our present thing, then our new variable will be given like, I mean the category will be converted like this one. So earlier there was that C hist was there. So the C hist now have been changed to like this one. Sorry, history has changed to like this one. C balance have been changed to these different indicator variables. Okay, so this is what dummies do. Okay, now next I am splitting my data. Splitting using train test split. You can go and refer to this link here. So in train test split, I am giving my x variable, y variable. So it will be stored to train x and train x and test x. Then y variables will be stored to train y and test y. The test size I have given as 0.2 because in the question it was asked to split according to 75-25 proportion. Then random state equal to 1 I'm giving because I don't want to shuffle the data the next time I'm running this program. Okay, so the shuffling should happen same in each and every instance the program is run. Okay, so I'm just putting, you can put any integer value there. So I'm just putting random state equal to 1. So this is train test set. Okay, now so I have splitted my data. Now train x, test x is there, train y, test y is there. So first, then I'll load logistic regression. This is the particular command which is used to do logistic regression function. Okay, now so
Ma'am?
Yes.
I had a doubt that the assignments which we are solving and submitting, no? So how we can view that assignment submitted means our colleges ask that at the end of semester, the assignments which you had solved, so you can submit hard copy of the same. So if I reopen it, so I can see the unsolved assignments, but when I had solved that, it has shown message that it is submitted.
When you give the answers itself, can you take a printout or anything? I'm
No,
not
that time
sure.
we were not knowing that. Yesterday only our college told that we have to give like that. So that's why okay means while taking printout, I will again take the answers and take print like that. Okay, I will do it.
Okay, I think you just have to ask in the ask in the ask a question tab. You just ask this question. Okay.
Okay, or second option is we can do like this also. Means just tick again and take print.
Yeah, that you can try. That is an option. You can try
Okay.
that.
Means as a part of submission, they have told yesterday that at the end of semester you can give like that.
Okay. Yeah, you try this method.
Okay.
Yeah.
Thank you.
Okay. So random state. So random state is like if that is not specified, your value will be shuffled the next time you'll be giving it and your value will be changing. Okay. So I'll just go to this one. Random state. Okay. You see, random state controls the shuffling applied to the data before applying the split. Okay. Yeah. So you can give any integer like some places I've seen like 40, 48, 42 like that is also possible. 1 is also possible. So if you put like that, your shuffling won't happen, it will be controlled. Okay, so next time also you're running, you'll get the same value. So okay, so I'll just load this particular logistic regression class to logis underscore mod, which is I'm giving, and maximum iteration I'm specifying as 10,000 because by default the number of iterations is 100 actually. Okay, just wait. Sorry, not this one. In the logistic regression, max iteration would be like default is 100. Okay. So I'm just giving an increased number, like 10,000 to get a good convergence. So then what I'm doing is like I'll fit my logistic regression model. So this is the way in which this logistic regression is applied to our data. So logis underscore mod dot fit train x train y will be given and it will be trained according to that. Then I'm using to predict my test values using the logis dot underscore mod model, and I'm storing the predicted values in prediction dot log. So I'll just run this program. Now, next thing. So in order to know the performance of your particular classification model, you have to check for the confusion matrix. Okay. So the confusion matrix is like I've just included analytics with your page actually. So in confusion matrix, you can see that your matrix comes like this one. Okay, true positive, false negative, and true negative. Okay, so these are your actual values. Actual values if it's positive or negative. So in your case, you can see like if the credit score is good or 1, it will be positive. Credit score is bad, it's negative. Okay. Likewise, the predicted values positive and negative, 1 or 0. Okay. So if your actual values are positive and your predicted is also positive, this will be coming in this column, true positive. Then if your actual values is positive and your predicted value is negative, it will be coming as false negative. False negative means it is predicted as negative, but the answer is false. So false negative means the predicted value is coming as negative, but the actual value is positive. Similarly, false positive means the predicted value is positive, but the actual value is coming as negative. Okay. Now, true negative means both the values are negative, like both the actual values as well as the predicted values will be coming as negative, or in this case, 0. So that is true negative. So I have a query, calculate values for all x test values. Yes. If you give like this one, logis underscore mod dot predict of text of x, then you will get all the values of test of x.
Please repeat the false positive in Confusion matrix.
What? Can you repeat?
Please repeat the false positive in confusion matrix. Interpretation of false positive.
False positive. Okay, just I'll go to that one. Yeah, false positive means in your data set, the value, the credit score is coming as bad. Bad means 0, that is negative. Okay, but when you gave the prediction, logis.mode.predict for that particular value, your answer came as 1. Okay, your answer came as positive. You predicted as positive, but actually it was negative. Is it clear now?
And any predicted value is 1.
Yeah, predicted value was 1,
And
but the actual value was 0.
Okay.
Yeah, I mean the 1 or 0 things will change by how you are giving it. Okay, but right now, I mean, it's like taken less. Positive value means 1, negative value is 0, so it will change like that. But right now it's like positive means the credit score is good, negative means the credit score is bad. Okay, so this is the metrics actually, and based on this metrics we have different calculations. Like you can just go through this one for everything. Now based on that you have accuracy, where that is the true positive plus true negative by true positive plus false positive plus true negative plus false negative. There are different examples also. Now some other things are precision, recall and all, but I think this is not asked in the question, but you can just go through this one if you have any doubts. Okay, and if you have any doubts you can ask also, but these are the different things. These are the equations. Recall means how many actual positive cases we were able to predict correctly with our model. And precision means how many correctly predicted cases actually turned out to be positive. Okay, so you can go through this. If you have any doubts, you can ask me later. So right now in this question, we are asked to find out the number of accuracy of the model. Okay, so right now it's the accuracy of the model we have to find out. So we'll just take the confusion matrix. This is the function we have to use, and in that confusion matrix the input should be like test y, that is our original thing, and prediction underscore log is the prediction that we have done on the test values. Okay, on the test x values. So these are the inputs, and the outputs of this one will be like, I am just given this one here, right? So I am just given .ravel will give you the different, I mean it will store the different values of this one to tn, fp, fn and tp. So this is coming here, and then I'm printing both the confusion matrix as well as the values. Okay, so if I do that, now we will get like the matrix will be coming like this one, and the values will be coming like this. Okay, so this is the true positive, true negative, false positive and false negative. This is the matrix. Okay, yeah. Now from this accuracy score, this is another thing, it is also there in the scikit-learn matrix. Scikit-learn dot, yeah, I think I have changed that. It is there in matrix, so you can go and see here scikit-learn.matrix, the matrix.accuracy score is there. Okay, so using that I'll just find out the accuracy score. In the accuracy score the inputs are like test y and prediction.log, and then I'm rounding the value. Okay, so the result will be coming like 74.8. Okay, now this is the accuracy which was asked in the question. Now if you want to find out the recall and precision which I've shown earlier, and also the F1 score, the F1 score is coming here. So this is the formula for the F1 score. Okay, so all these can be found out using this one. Precision means we just applying the equation for that. Okay, precision, recall and F1 score, and I'm just printing these values. Okay, so I think This is fine with everyone. And next question is like, I have to print the misclassified samples. Okay, so misclassified samples means what? My test value, I mean the original target variable, which is good or bad, coming like good or bad, is not same as our predicted one. So that will point to the misclassifications where we don't have a classification. I mean the classification has not come as correct. Okay, so I'm just giving that particular condition here, test y not equal to prediction log, and then I'm taking the sum. So this will give you the number of misclassified samples. So the question accuracy is asked like this one, and the number of misclassified things also we have calculated. So the accuracy is of the model is coming like 74.8. So C is the answer. Okay. Now one have asked, did we use classification report? We didn't use classification report for this one. Okay. So that is also similar only, but you have to load classification report also, that is loaded there. And for that, based on this thing, okay, just wait. Yeah. Classification report can also be printed. Okay, so in that also the inputs will be coming like this one, and I'll just see to print that one since it was asked. So classification report will be coming like this one. Okay, I think it's clear, Uma. This is what the classification report will show. Okay, it will show the precision recall FN score for each of the different classes. Different classes means the credit score is good or bad. Okay, so for each of the different classes, the precision recall FN score, everything will be given. Okay, that also is in the scikit-learn metrics. And okay, where is the classification report? I can't see it right here. Okay, just I'll load it there. It will be here itself, I think. Wait, I'll just search. Classification report. So scikit-learn metrics itself has classification report. This is the classification report. Okay. Now, could you suggest any website to download Excel sheet for workout? You can try mostly Kaggle actually. Kaggle or Data World is there. Okay. Kaggle you can try. Now, what is the exact difference between classification and regression? Yeah, almost all calculations are similar for both these, but in classification, your target variable will be a categorical variable. Okay, and in regression, your output would be like a continuous variable. That is the basic thing you can find out. Here our target is like credit score, that is having two classes, either good or bad. So we are classifying all the customers that are present in this particular data set as either good or bad. So classification means classify your data into two separate or three separate or different classes. Okay. Regression means it is like you will predict a continuous variable. Okay. So I'll come that regression problem is also coming later. When I'm discussing that, I'll tell you what's the difference. Okay, Shruti. Okay. So so we saw the classification report also. Sorry, I think Your program code will be posted in the Google Drive link. Okay, you can take it from that. Okay, so we have seen the confusion matrix, classification report, and also got the misclassified samples. Okay, now the next question is like import standard scalar. I think you have learned this in your week 4 videos. So standard scalar is used for standardization. Okay, so it should be used from scikit-learn.preprocessing package to standardize the feature. Okay, so this is our question. Then they have asked us to use the same train test proportion and the random state should be set to 1. After standardizing the logistic regression model, by what percentage has the misclassified samples changed? So right now the yes, is anyone having any doubt? Okay, so right now the misclassified samples is 63. So we'll see what after standardization what happens. So standard scalar means the scikit-learn link I have given, scikit-learn.preprocessing is the place where the standard scalar is given. Okay, that is the library. This is the API reference for that one. And these are the different parameters. If you want to see what it does, I have given you a link, standard scalar and min-max scalar. These are usually the different scaling models which are used. I'll just increase the things. Okay, so here you just see the different things are there. You can just read what is normalization and standardization. So data standardization means rescaling the distribution of values so that the mean of the observed values is 0 and the standard deviation is 1. So it is usually like your data minus mu by sigma mode. Okay, like that your data will be standardized. Okay, yes, that's good. So you can read through it later. Now this is, so standard scalar is used for that standardization. So the question has asked us to standardize the features first. Okay, so standardizing means it's applied to the numerical columns. So age, C amount, duration, installment rate. So these are the different things. Okay, these are the different numerical columns: C due, C amount, in rate, then age, in credit, so number of existing credits, and depend. So the different, I think I have missed C amount. Okay, so these are the different numerical values. So we have just taken the column names of those numerical columns. Okay, so we can standardize only the numerical columns. The others are categorical. We don't have to do that. We have just encoded it to different variables using the pd.getDummies. Okay, so we don't need to do anything, any scaling there. So we have just selected the numerical columns from there and we have taken that particular numerical columns and put the train X in the features variable. Okay. Now, what to do is like standard scalar. This is the function. So we have fitting the values of those features. I mean, we are taking the features and then getting the values from them. Okay, and we are fitting it using a standard scalar. Okay, is somebody muted, unmuted? Okay, so we are just, I'm just giving the standard scalar to this one and I'm transforming the values of this one and storing it in features itself. Okay, now what I'm doing is like these features I am giving in that particular location. So I'm changing the train X values also because first I've stored in features, then I'm storing, I'm restoring it in train X because we'll do that logistic regression with train X, train Y, test X and test Y. So I'm just changing the train X and test X values with the standardized values which were obtained. So what I'm doing is like just using the scalar to transform the features, and the features first it will contain the train X values Next, it stores the test X values with the column names that we have given. Okay. So if I run this particular thing, the test X and train X values will be changing, will be standardized. How can I run program during the exam? That can you just ask the in the ask a question section? I'm not very sure about it. Okay. John, are you clear with that? You just ask the portal itself.
Where is that ask question section?
It's right beneath, not beneath, it's right in that. Can anyone answer? I have to just take the
Ask forum,
Yes.
ask forum session is
In our
there. No?
ETL, yes, it is available.
Yeah, in the
NPTEL course.
NPTEL itself, yes.
Ask forum.
Ask a question like that, it's present. I have just not logged into that portal actually now, just now. So someone can help. Okay, you can just search your tab actually. It will be there. Ask a question tab. Okay.
Okay.
Yeah. So now what I'm doing is that earlier I have done the logistic regression without standardization. Now I am just calling the logistic regression function and I'm fitting to the new standardized values. So trainx has the standardized values in the trainx and also the testx also has standardized values. So I'm just running the logistic regression again on these values. Now, so I've given a different name. Earlier I had given the prediction values and stored it in prediction._log. Now I'm giving the predicted values in prediction_log_stn. Okay, standardized. Okay. So I'm just giving it like a different name. And I am doing all the things which I've done in the earlier question itself, like finding the confusion metrics. Here also you can find out the classification report. So I'm just running this again. Now this is the present classification report with TP, TN, FP and FN. Now I'm just finding the accuracy score again. This particular case, the accuracy score has come like this, 77.6. Now, if you find out the misclassified samples here, the misclassified number is coming as 56. Okay. Earlier it was 63. Okay. So in this question, we are asked by what percentage has the misclassified samples changed. So right now it is 56 here and earlier it was 63. So 56 minus 63 by 63 will give you the change. Okay. For that, I'm just using this thing, okay, because I have put test y not equal to prediction log stn here. That is the case for this particular standardized case. And I've just put it here. You can put it to a variable and do this calculation. I've just now given it like this only. So this is the same. I mean, this will give you 53, this 56, the other one, this particular portion is 63. And this particular portion is also divided by 63 into 100. Okay, so if I run this one, the percentage is coming like minus 11.111%. So your answer will be coming like A. Okay. So I hope this is clear. Let's move on to the next question. Okay. So when KNN classification is applied on the same standardized data. So right now, earlier we have used logistic regression. Now, if you use KNN, K nearest neighbors classifier, the accuracy achieved is what? It is asked. Okay. So for K nearest neighbors, we have to use sklearn.neighbors import K neighbors classifier. I hope you have learned about these. Now I have just given K neighbors classifier API in scikit-learn library in a link as well as an example to use that. So this is K nearest neighbor. So your intention is like you will select a data point and depending on the K value, you will fix how many nearest neighbors are there. So if your K value is 1, you will be checking one nearest value and we will be checking whether it's a yes condition or a no condition. Okay. So you can read more about it, and in your week videos also it will be there. So our present question is like apply k neighbors classifier. Okay. So they have also asked the optimal value actually. Okay. So optimal value for k neighbors classifier is asked. So we don't know what value of k to be given. Okay. So for that, what I'm doing is like just I'm giving like misclassified sample is equal to just an empty set and accuracy scores k another empty set. So we want to see for which value of k we'll get nice optimal values. So I'm putting I value as in range 1 to 25. So k value is set to range from 1 to 25. Okay. Now I've put k neighbors classifier with neighbors equal to I, and metric is Euclidean. So all about the metrics you can find here, and the different types are there. Okay. So I have just given that in a standard Euclidean distance. So in that knn underscore mod dot fit train x and train y and pred k underscore I will give you the predicted values. Okay. The steps are same, just instead of logistic regression here, I'm giving k neighbors classifier. Okay. Now, for each of the I values, I'm classifying the misclassified sample and accuracy score. Okay. So misclassified sample means our test y is not equal to the predicted value. Okay. So that sum is given. So this is just a simple program only. Like misclassified samples, for each value I'm appending for each instance of I in each iteration, and accuracy scores also I'm appending. Okay. So if you run this particular thing, you can see that the list of accuracy scores will be ranging like this one. Okay, so these are the different accuracies obtained, and maximum accuracy is obtained is 78% at k equal to 15. So if you want to see clearly, I'm just giving the print in the for loop itself. So if I give like that, I'll be see for k equal to 1 accuracy score is 66%. For k equal to 2, like that it will be listing. Okay. So from there you can find out for k equal to 15, the accuracy score has come as 78. Okay. So this is answer is B. Okay. The accuracy achieved is 78%. Now we'll move on to the linear regression problem. So till now I think it's clear for everyone. If you have any doubt, please ask me. Okay, then I'll move on to the next thing. So just a minute. Yeah. So a multiple linear regression model is built on global happiness index GI report.csv. So, okay. For this purpose, I have loaded the GI report.csv. Now, what is the RMSE, root mean squared error of the baseline model? Okay, so many things are coming up here. First, you want to know what is the baseline model. Then you have to find out the root mean square error. Okay, so first I'm loading that particular data into data underscore GHI. Okay, so this is the data frame, and in that data frame I am just separating the features as well as target. Okay, so I'm just giving like extracting the different columns. So you can see here the CSV file will be showing like these are the different columns there, and 158 entries are there present. So I'm just extracting the columns. So set of data underscore GHI dot columns will give you the different columns present in the data frame, and in that I am minusing H score. Okay, that means that is my target. Okay, so H score is my target. So in this particular case, you can see here economy, family, health, freedom, H score. So in this case, the target variable, the target column is a continuous type. Okay, this is not a class actually. So in a regression case, your target variable will be a continuous variable, won't be classes. Okay, so in earlier case, in classification case, the earlier example had shown like whether the credit score is good or bad. Okay, so there are two different classes. In this case, the report has shown like the target variable also some continuous values will be coming. Okay, so in this type the prediction will be like you will be predicting a value, you won't be predicting as whether they will come in one class or another class. Now you will be predicting like what is the value which is expected. Okay, so this is the difference between regression and classification. Okay, so I'm just giving the target as well as features to separate variables, and I'm printing both the features as well as the targets. So features I'm taking as FAM, freedom, economy and health, and H score I'm giving as the target. Okay, so these are the different variables or the column headers actually. Now, based on this column headers, I am giving the log function so that I can split the data into X and Y. Okay, so data.ghi.loc, LOC I have discussed last week. So I'm selecting all the rows, and in features I have the independent variables, that is FAM, freedom, economy and health. So all this will be going to X, and Y will contain the values of the target. Okay. Now, again, I'm using a train test split here. So for regression problem also, you can use the same thing. X comma Y comma test size 0.25 means you will be having a 75-25 proportion, and random state I'm putting as 1. Okay. So it will be stored to train X, train Y and test Y. Okay. Now our intention is to find out the mean squared error. Okay. So for that, I'll import from sklearn learn.metrics mean squared error. So you can see about mean squared error here in this particular link, how it is calculated and all. And if you want to know the theory about a baseline model, because in the question we are asked to find out the baseline model of RMSE of the baseline model. So baseline model means, I'll just go to the link and explain. So baseline model will vary for classification and regression. So right now our problem is regression model. Okay. So regression model requires the prediction of a real value, and in this particular case, a default good default prediction for real value is to predict the central tendency, that means the mean or the median. Okay, so in that case the baseline model will also be taking the mean or the median values. So for that in that case we will be taking the mean values here actually for the base model. So base spread equal to just giving np.mean. We are taking just the test values and np.mean of test y. So test y values mean will be taken and it will be stored to base spread. Okay, and just base spread will be printed. Okay, so I'll just print that separately. So what you will get is like this H score mean value will be coming like this one. Okay, now I'm just repeating all these values because I'm constructing a baseline model, right? So baseline model should have the mean values there. So I'm just putting np.repeat. So repeat is a function which can repeat the given data the number of times. Okay, so given data is the mean value which was calculated, and len of test y means how many test values are present, how many y values are present.
Ma'am, please repeat the base model concept or baseline model.
Yeah, baseline model is a model. Okay, so the initial one I'll go. So baseline prediction model. Okay, we want to know whether the prediction for a given algorithms are good or not. Okay, for that a baseline prediction algorithm is created, and the baseline prediction provides a set of prediction that you can evaluate as you would any predictions for your problem, such as classification accuracy or RMSE. Like means the baseline model means that it's a simple model to establish your baseline performance on a predictive modeling problem. Okay, just you are considering that particular model as your best model, best output you will be getting from that model. Okay, is that clear?
Yes, ma'am.
Yeah, so usually baseline models are present for classification as well as regression. So since our problem is a regression model, there are different rules for creating baseline models, but for right now, for regression, the best thing is like you want to create a model which predicts the central tendency. Okay, central tendency means it can be the mean or the median. Okay, this is selected depending on how your data is distributed. If your data is distributed without any skewness, okay, if it is correctly normally distributed, then you can go for the mean. If it's having some skewness, okay, then you can go for the median. Okay, so right now in this case our baseline model is created with the mean. Okay, so we have just taken the mean of the values of the test y, and we are repeating these mean values to create the baseline model. Okay, so base underscore pred we have given, and we are repeating the mean values that we got this much number of times. Okay, now we have both these things actually. So because we have the original test y and we have the base spread. Okay, so we are just finding out the mean squared error. This is the function to calculate the mean squared error, and we are finding the mean squared error between the test y values and the base spread values, which contains the repeated values of this 5.34. Okay, so this is the mean squared error, and we want to find out the root mean square error. So first we will take the root mean squared error and then find out the square root. There is also a function for directly finding this one, RMSE, like that. So this is, I've just given, if you are using NumPy, then you can use sqrt, square root of mean squared error, and it will give you the mean squared error value. Okay, sorry, I just didn't run this one. So, okay, so base spread equal to np dot repeats base spread this much number of times. And if I am running this again, your mean squared value of the base model will be, mean squared error of the main base model will be coming as 1.06. Okay, this is clear now. Print the output of base spread. Okay, so okay, if I just print that, it will be repeated many times. You can just see some values. Okay, now can you see the same thing will be repeated, 5.34. Okay, yeah. Now, any other doubts? Okay, then. Okay, then let's move on to the next one. From the multiple linear regression model built on the GHI index, we get an R squared value of test data subject. So you can, you are asked to calculate the R squared value. Okay, so what is R square? So I've just given some links about linear regression, multiple linear regression, and coefficient of determination R square. So for that, we want to import some things because we haven't used linear regression till now. That's simple only, but you have to import these from the scikit-learn. So in scikit-learn.linear model, linear regression is present. Okay, so what is linear regression? I have included a link actually. You might have learned that also. It's depending on this function actually. And with this one, we are predicting the values. Okay. So you can just go through this link later, and you can also get that from your videos in the week 4. Now the coefficient of determination R square. This is the coefficient of determination. It is used to evaluate the performance of a linear regression model. Okay. So this is the equation actually 1 minus SS res by SS total. Okay. So this is the sum of squares of residual errors and total sum of the errors. Okay. If you want to understand what is, you just go through this link. It's simple only. Now, if you want to calculate with this using Python, you have to use scikit-learn.metrics and import R2 score. So for that, first we want to construct the linear regression model. So I'll name it as linreg_mod, and I'll fit my train and train X and train Y values using this model. Okay. So linear regression is done. And next what I'll do is that I'll find out the linear regression score. Okay, so I'm just putting linreg_mod dot score, okay, of this one. Okay, so if I do that, I'll get the score, okay, of train Y, train X, train Y, and test X, test Y. Okay, and then just rounding the values and obtaining it. Okay, so this is R2. So how it is calculated? It is calculated by 1 minus sum of squares of residual errors by total sum of errors. Okay, you want to get one value to know if your regression model is very good. Okay, one denotes a very good regression model, and if it's closer to 1, your model is the constructed model is very good. Okay. Is this clear? If it's clear, I don't see anything in the chat. Okay, next, let's move on to the next one. Okay. Now, which of the following statements about linear regression is or are true? Okay, I think you can just see here, answer is given already, because the first one, linear regression assumes that there exists a linear relationship between independent variable and dependent variable. That is the important thing actually. Okay, linear regression relationship is assumed. If you find your data set is not having any linear relationship, or otherwise if there is a very non-linear or relationship present, then you shouldn't go for a linear regression. So that will be obtained whenever you run your model and see the linear regression values and the errors. If the error is too high, that means that you can't use it due to the nature of your data present. Okay. Now the error terms are assumed to be independent and normally distributed. That is one thing. Then the percentage of variation in the dependent variable by the independent variable is expressed by the R-square value. Okay, that is one thing to do. Now, residuals are the product of predicted value and the actual observed value. So this is the wrong statement. Actually, the residuals are the difference between predicted value and actual observed value. Okay, so residuals, this is the option D is the incorrect option. So all the rest are true. Okay. Now we'll move on to this question. Yes.
What is the role of R square and adjusted R square in model?
R square will tell you whether your model is created perfectly. It is used to evaluate the performance of your model. Okay. I mean whether your product model has predicted clearly or not. Is it fine?
Yes, yes.
Yeah.
Yes,
so I mean for that.
Adjusted R square.
What?
Adjusted R square.
Adjusted R square is another thing. It is calculated by dividing this one. The equation changes actually. Okay, you can just search it anywhere.
It is divided by the degree of the freedoms. But what is the role of the adjusted R-square in the model?
I think I'm not very sure about that. You can just search it there. I mean, adjusted R square will give you the percentage of variance by only the independent variables. Okay, you can just search somewhere else actually. Yeah. So adjusted R square. Yeah. So adjusted R square, it will take into account the number of independent variables used for predicting. Okay, that will also be considered. So R squared statistic, in some cases, it will not come in a right way. Okay, so in those cases, you will be going for the adjusted R square. So what you can say is that I think I to point you to a thing. Okay. I'll just share the one thing which I'll see. Okay.
Okay, ma'am. No problem.
Yeah, I am not finding the thing where we can mention you the difference. Okay, I'll share that in my notebook. Okay. Now, which of the following statement is inaccurate about logistic regression? Okay, which is inaccurate? You can directly say that. You can put in the chat window. Logistic doesn't require a linear relationship. Is that right? Or the value of logistic function being a probability will range from 0 to 1, then cost. It's also called, so which is the inaccurate about logistic regression? The dependent variable can be of numerical and categorical type. So this is the inaccurate statement. Okay, so only categorical dependent variables are possible. So that is true, Abhishek. Yeah. Now next one, in a KNN model, by which means do we handle the categorical variables? So answer is given. How do we handle the categorical variables? Yes, dummy variables are created. We have seen that pd.getDummy is there. So to handle the categorical variables, you can use this one. Okay, there are different encoding options also. I am not sure if you have learned this in your week 4, but you can just check out the one hot encoding and all those options. Okay. So these are the 10 questions. So dummy variables can be used to encode the different values contained in a particular categorical independent feature. Okay. So these are the different questions that were present in week 4. Okay. I hope you have understood. If you have any other questions, please ask me. I'll be sharing this notebook with you, and in that I'll be including the data for the adjusted R square also. Okay. Okay, then I think I can stop this session. So thank you. Yes, thank you everyone for listening. Yeah. So it was a wonderful session. Thank you. Okay. You can
share the link, please, ma'am.
Thank you.
Share. Links are included in the notebook. Okay. You can just click there.
One doubt.
Yes, tell me.
How are categorical variables proposed before model building?
Proposed meaning? What do you understand by that?
Pre-processed. Hello?
Tell me.
How are the categorical variables pre-processed before model building?
Categorical variables.
Variables, correlation.
Yeah, I mean, you can encode that to different values. Okay, one of the pre-processing step that I have shown here was like, okay, in the first case, our categorical variable in this credit worthiness dot excel, that value was credit score either being good or bad. Okay, so in that case, what I did is like just encode the data as 1 or 0. So the good one I have encoded as 1, the bad one I have encoded as 0. Okay.
Yes, ma'am. Thank you.
Yeah. So you can find encoding in different methods actually. You can use label encoding. Okay, just search label encoding. Label encoding, encoder scikit-learn if you want to use. So this is like encode target variables with value between 0 and n classes. Okay. Is it clear now?
Yes, ma'am.
Yeah.
Thank you.
I mean, if you have only 2 target variables, you just have to map yourself. I mean, you can just do by yourself also. You don't have to use a label encoder. If you have multiple classes, you can go for the label encoder option. Okay. Yeah. And the other case will be having the one hot encoding. Usually it's used, the independent variables. Okay. Anyone have any other question?
No, ma'am.
Okay then. So okay then. I'll stop the session. Thank you for listening. Okay. Okay.